I'll give some notes along with the graphical analysis today. So can anyone tell me what is the condition of consumer's equilibrium?
Px by Py is equal to Ux by Uy.
Very good. MRS xy is equal to Px by Py. Or Ux by Uy is equal to Px by Py, whatever. Slope of the indifference curve is exactly equal to the slope of the budget line, or absolute slope of the indifference curve is exactly equal to that of budget line. So this is given by, this is consumer's equilibrium, and logically we try to understand why this equality is giving the equilibrium. What is the problem if MRS xy greater than Px by Py and MRS xy less than Px by Py? So when MRS xy, that is Ux by Uy, is greater than Px by Py, the valuation of x with respect to y is greater than the cost for x with respect to y. The utility you are getting from additional unit of x, that is greater than the price you are paying for additional unit of x. So in that case, any rational consumer will continuously increase consumption of x, and that in turn means reduction in consumption of y. And when this takes place, that is Ux by Uy is less than Px by Py, that means for additional unit, the value is less than the cost you are bearing. The additional utility you are getting, that is lesser than the price of X you are paying for that additional unit. And naturally, it will indicate reduction in consumption of X and increase in consumption of Y. So keeping these points in our mind, today we will talk about corner solutions first. Corner solutions. Last day, this MRS xy is equal to Px by Py. This equilibrium condition is giving interior solution. Okay, so let's consider a few cases. We are considering this line as the budget line for all the cases. When the commodities are perfect substitutes to each other, what will be the shape of the indifference curve? Anyone? If the
Linear.
linear, very good. If the commodities are substitutes to each other, X and Y are perfect substitutes to each other, in that case, the indifference curve or the entire map will indicate the indifference curves, where indifference curves are nothing but negatively sloped straight lines. Indifference curves will be straight line, negatively sloped straight line. Okay. So the set of red lines here in the first diagram, that is indicating a situation when X and Y are perfect substitutes to each other. X and Y are perfect substitute to each other. Now, if the black line indicates the budget line, can anyone tell me whether the slopes of the ICs are steeper or flatter compared to the budget line?
Steeper.
Steeper.
Steeper. So, am I talking about the first case then? If the ICs or the slopes of the ICs are greater than that of the slope of the budget line, are we talking about this situation? MRSXY greater than PX by PY for the entire budget line? Everybody?
Yes, ma'am.
Okay. So in the first case, so let's mark the points. It will be easier. So in the first case, I'm considering a two commodity world. X and Y being two commodities the consumer consume. AB is the usual negatively sloped budget line. And I am considering X and Y are substitutes to each other. X and Y are perfect substitutes, giving a set of parallel negatively sloped straight line curves. Indifference curves are negatively sloped straight line curves. So these are nothing but okay. So all along the budget line AB, we are finding that ICs are steeper. Whatever IC you are considering, the budget line is flatter than that of the slope of the indifference curve. So a rational consumer will continuously increase consumption of X and reduce consumption of Y, and finally the consumer will stop at B. Okay, because beyond B we have to move to the negative quadrant, so we will be not able to increase consumption of X beyond B. So consumer is continuously substituting Y by X, and finally the equilibrium will be achieved reaching at the corner given by B. It is a corner solution, so it is not a solution along any point on the budget line within A and B. Rather, consumer's equilibrium will be achieved at B, which is a corner solution. Since MRSXY is greater than PX by PY, all along the budget line AB, consumer will be more and more satisfied reducing her consumption of Y and increasing consumption of X, and finally the consumer will stop reaching at B, and B therefore will be the consumer's equilibrium, which is a corner solution, which is called a corner solution, or mono-commodity equilibrium, single commodity equilibrium, mono-commodity equilibrium. B is a corner solution where the consumer is consuming only X. Consumer is consuming only X. So it is a single commodity or mono-commodity solution. On the other hand, if this happens, suppose again the commodities are perfect substitutes to each other. Y and X are two commodities. A and B, AB is the budget line. And I have IC1, IC2, IC3. Set of parallel indifference curves, negatively sloped parallel indifference curves. The curves are,
But they're all flattened.
yeah, very good. Curves are linear, okay, indicating commodities are perfect substitutes. However, all along the budget line, the ICs are flatter than that of the budget line. ICs are flatter than that of the budget line. So all along the line, the second thing is happening. The second thing is happening. MRSXY is less than PX by PY. MRSXY is less than PX by PY.
Which means the consumption of Y is
Consumption of
increasing.
consumption
Commodity.
is increasing. Consumer will be more and more satisfied if she can continuously reduce consumption of X and increase consumption of Y. Y is always more valuable to the consumer with respect to the price she is paying for Y. Okay, so in that case, finally the consumer will stop at A, because beyond A, it will be not possible for the consumer to increase consumption of Y. So consumer needs to stop at A, okay, because the points above A are not feasible given the budget AB. Given the fact that it is a constraint optimization, consumer needs to stop coming at A. So A is again, as we are finding, a corner solution, because consumer is consuming only one commodity at the end. It is not an interior solution. For any interior solution along the budget line, consumer will consume some amount of X and some amount of Y. However, here she is consuming only Y. Okay, only Y. So it is again, as you are understanding, it is a corner solution. Consumer will consume OA amount of Y, OA amount of Y at equilibrium. In the first case, the consumer will consume OB amount of X at the end, OB amount of X at the end. This horizontal intercept gives the amount of consumption of X in the first case, whereas the vertical intercept of the budget line gives the equilibrium consumption of Y in this case. So what is the solution here? How much X the consumer is consuming in the first case? Can
OB.
any,
In the first case, consumer is
OB.
consuming OB.
how much X?
OB, ma'am.
OB graphically, if the budget line is given by XPX plus YPY is equal to I, how
I by px.
writing the budget equation? So in the first case, what is the amount of X the consumer is consuming?
I by px.
I by px.
By PX. Very good. Just- And in the second case, 0,
I by
I
PY.
by PY.
I by PY.
Okay, so in the first case, the consumer is consuming I by Px amount of X and 0 amount of Y. In the second case, the consumer is consuming 0 amount of X and I by Py amount of Y. Okay. Next, instead of considering this kind of perfect substitutability between the commodities, I can consider weak convexity. Okay, so I'll come to these cases. At this moment, you don't need to draw the diagram because I'll introduce the idea. However, just I'm telling you, instead of considering this kind of linear diagram, I can consider the diagrams like this. Linear line is also weak convex. And here too, the lines are weak convex because, you know, the part of the horizontal axis here and here, the part of the vertical axis, these things are coming. Part of the vertical axis, part of the horizontal axis here are coming as the part of the indifference curves. So not necessarily that the commodities should be perfect substitutes if I want to have a corner solution. Okay, so just to tell you that thing, I am considering the second set of diagrams where the commodities are not perfectly substitutes to each other. The indifference curves are convex. However, the curves are only weak convex. Okay, so in that case also there is a chance that the consumer will have corner solution. The consumer will have corner solution because here in the first case, the slope of the indifference curves always along the budget line is steeper, whereas in the second case, the slope of the budget line all along the budget line is flatter. The slope of the indifference curve all along the budget line is flatter. Okay, so to have a corner solution, it is not that the consumer or the commodities should be perfect substitutes to each other. In some other circumstances too, we can have a corner solution or mono-commodity equilibria. Okay, so coming back to our slide, so already the things are with you. So here I want to indicate it is not necessary that always we will end up with an interior solution. If all along the budget line, the indifference curves are flatter, in that case, consumer will stop at this corner where the budget line is intersecting the vertical axis, and in that case the consumer is consuming I by Py amount of Y and 0 amount of X. On the other hand, if the indifference curves are always steeper, in the Ux by Uy is greater than Px by Py all along the budget line, in that case, the consumer will stop consuming I by Px amount of X and 0 amount of Y. Okay, so you can mark these two cases. I think already you marked. Now, any question in understanding the issue of corner solution? Anyone, any question?
Ma'am, can you please repeat weak convexity part?
I'll repeat. I'll cover this in detail. Just I am asking whether you are understanding the idea of corner solution or not. If you understand the idea of corner solution, one by one, I'll consider different possibilities. So idea of corner solution, is it clear?
Yes,
Yes,
ma'am.
Yes,
ma'am.
yes, yes.
Okay, so now give heading some special cases. Some special cases. So now I am going to analyze the concept of consumers equilibrium for different special cases. Okay. The first is allowing weak convexity. First case. Number one, allowing weak convexity. Allowing weak convexity. Please add weak convexity permits the indifference curves to be linear, indifference curves to be linear, or to have linear segments. Linear or to have linear segments. So first you draw figure 1a. Consider a two commodity space x1, x2. Consider a budget line KL. Here you give the name KL, the budget line KL. So here you put KL. And then you draw the indifference curve in such a way so that between the two curvatured part, there is a straight line stretch. There is a straight line stretch. AB is a straight line stretch. So please add, in figure 1a, the budget line is seen to be coincident with a linear segment of the IC. As a result,
Ma'am, can you repeat once?
in figure 1a, the budget line is seen to be coincident with a linear segment of the indifference curve, linear segment of the IC. As a result, all the points on the budget line, all the points on the budget line between A and B are optima. All the points on the budget line between A and B are optima. Since here there is number of optimum solution, we are calling optima. Okay, so there is a possibility that we are not getting a unique solution. Rather, we are getting a number of solutions which are equally likely. If, you know, the indifference curve merges with the budget line, in that case, we are getting a number of optimum solutions. Okay, so we are getting optima along the entire straight line stretch of the indifference curve AB in figure 1a. Next, I think already you have considered this kind of case which I have written in, which I have considered in figure 1b, the possibility of corner solution. Here I am considering IC to be flatter. It can be steeper as well. So figure 1b illustrates the possibility that the IC has a different slope to the budget line. IC has a different slope to the budget line. The equilibrium lies at point B. Equilibrium lies at point B on the x2 axis. On the x2 axis, since any other point on the budget line, lies on a lower IC, This type of solution is called corner solution. Or monocommodity equilibrium. This type of solution is called the corner solution or monocommodity equilibrium. As an extension of figure 1b, we may consider the following cases. As an extension of figure 1b, that is, as an extension of the corner solution, we can consider the following cases. So you can consider figure 2a and 2b. We have already done 2a and 2b. AB is the budget line. X1 and X2 are two commodities. In the first case, ICs are all steeper. In the second case, ICs are all flatter. Please add, if the ICs are such that MRS XY, MRS X1, X2, sorry, MRS X1, X2, if ICs are such that MRS X1, X2 exceeds P1 by P2 everywhere along the budget line, if the ICs are such that MRS X1, X2 exceeds P1 by P2 everywhere along the budget line, the consumer will purchase only X1. Here, the consumer is willing to pay more for X1. The consumer is willing to pay more for X1 than she requires to pay for X1. UX by UI is greater than P1 by P2. So I'm willing to pay more. I'm paying only P1. However, I am willing to pay more. So here the consumer is willing to pay more for X1 than she requires to pay for X1. Therefore, she increases X1. Therefore, the consumption of X1 increases. Therefore, the consumption of X1 increases up to the limit of her budget. Therefore, consumption of X1 increases up to the limit of our budget below which X1 is negative. Thus, the consumption of X1 is given by OB is equal to I by P1. OB is equal to I by P1. Here I have one question. Is it a point of tangency? Is B a point of tangency between the indifference curve and the budget line?
No.
What do you think? Anyone, please try. Is
May
it
not be.
tangency?
It is not a
Why you
tangent.
are telling it is not?
I think
What?
it is because
Why
it
you are
is
telling it?
meeting only at one point.
Exactly.
Better to say the two lines IC2 and AB are intersecting each other, isn't it? The
Yes,
Yes,
ma'am.
curves
ma'am.
are
Yes, ma'am.
intersecting each other. If I extend the curves, we will find that the B is not at all a point of tangency, though we are calling it equilibrium. However, it is not at all a point of tangency. We call this a point of contact. Okay, so please note that, take a note. The equilibrium considered in context of monocommodity equilibrium, the equilibrium considered in context of monocommodity equilibrium is only a point of contact, within bracket, not a point of tangency, bracket close, between the budget line and the indifference curve. Between the budget line and the indifference curve. It is a point of contact only. It is not at all a point of tangency between the indifference curve and the budget line. At equilibrium, the two curves are cutting each other. It's not a point of tangency. Okay. Now, next, let's consider 2B.
Ma'am,
Any question?
yes, ma'am. Ma'am, can you repeat the last line?
Would you please be a
Yes,
bit
ma'am.
louder?
Ma'am, can you repeat the last line for the note?
Okay. So B is only a point of contact, not a point of tangency. Okay. What I am telling that, basically at B, the IC and the budget line are cutting each other, intersecting each other. We call it a point of contact. However, it is not at all a point of tangency. Okay, got it now?
Yes, ma'am. Thank you, ma'am.
Next, similarly, if Similarly, if MRS x1, x2 is less than P1 by P2 is less than P1 by P2, everywhere along the budget line, then the consumer will buy only X2. Then the consumer will buy only X2.
Ma'am, can you repeat from similarly once more?
Similarly, if MRS X1, X2 is less than P1 by P2, everywhere along the budget line, then the consumer will buy only X2. The consumption of X2 is given by the limit. The consumption of X2 is given by the limit. Next, OA equal to I by P2. If the commodities are perfect substitutes, ICs will be negatively sloped straight lines. ICs will be negatively sloped straight lines. And here there are three possibilities. So you are already familiar with figure 3A and 3B. And here I have added one more diagram, 3C, where the ICs are parallel to the budget line. The budget line in every context is given by AB. Okay. In the third context, the budget line is merging with one of the ICs because the slope of the indifference curve and the budget line is equal. So there are three possibilities, 3A, 3B, 3C. Okay, so for 3A, MRS is greater than P1 by P2. So consumer consumes only X1. In 3B, MRS is less than P1 by P2 and consumer is consuming only X2 at the limit given by OA. In figure 3C, consumer can consume either X1, either at A. In figure 3C, consumer can consume either at A or at B. Or at any point between A and B. Consumer can consume either at A or at B or at any point in between A and B. within bracket, for example, at E. For example, at E, capital E. So all the points are giving a series of optima. So A, B, any point in between A and B are identical to the consumer because all the points are lying on the budget line. So here we are getting infinite number of solution. In the last case, we are getting infinite number of solutions along the budget line because the budget line and the IC is perfectly merging with each other. So here we are not getting any corner solution, interior solution. All solutions starting from A to B are equally likely. Any point can be consumer's equilibrium. Okay, just add one more sentence. A monocommodity equilibrium is also known as a monocommodity equilibrium is also known as monomania. 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 Okay. So the first subcase is complete. Now 2. Under some special cases, the first context, that is allowing weak convexity, this part is over. Now come to B, and then now come to 2, number 2. Give heading, allowing concavity, allowing concavity, concavity. Okay, allowing concavity. So I have drawn 2 varieties. X1 and X2 are measured along the horizontal and the vertical axis respectively. AB is the budget line and IC is concave here. The IC is touching the budget line at point capital T. So draw both for A and for B. Actually, in case of 4B, if you consider the second indifference curve, it will not pass through point A, rather it will be like this. And if you consider the third one, it is getting like this, so it will not come at point B.
Ma'am,
Yes.
ma'am, is that blue line indifference curve?
2 lines,
Blue lines indifference curve. Are
2
they
lines
indifference curves?
meet each other. Okay, just I'm showing you. Actually, I want to mean this possibility.
No, ma'am. I mean like that blue lines are there. That are the indifference curves.
Your voice is not that clear to me, so I'm not getting your question perfectly.
Ma'am, he is trying to say the blue lines you have marked, are those the indifference curves?
Yeah. Definitely. Definitely. All
Yes, ma'am.
concave lines are indifference curves. All concave lines are indifference curves. And the red linear line is the budget line. AB is the budget line. Whereas all blue curves are nothing but indifference curves. Could you complete drawing the curves?
Yes, ma'am.
Yes, ma'am.
Okay, everybody could finish? Yes or no?
Yes, ma'am.
Yes, ma'am.
Okay. So now stop writing. Stop writing anything because I'll give you the note on it too. Now the question is how in the reality we will capture consumption using concave indifference curves. Linear we understood, because if the commodities are perfect substitutes, in that case the indifference curve will be linear. Okay. Now I am telling indifference curve is concave, you know, in the entire map, the ICs are concave to the origin. Now the question is, in reality, is it possible to have concave ICs? Concave ICs means, the along the indifference curve as you are continuously moving from x2 towards x1 axis, the slope of the indifference curve is becoming steeper and steeper. For a convex indifference curve, we understand diminishing MRS, diminishing marginal rate of substitution. However, here what we are finding that the slope of the indifference curve will become steeper and steeper as we move from the left towards the right. Okay, the question is what kind of consumption will be captured by the concave indifference curve, or is there any possibility in the reality that this kind of consumption pattern will be captured by the concave indifference curve? So some people had economics at the +2 level. So can you suggest anything? Anyone suggest anything? Can we have concave indifference curve in reality? Anyone?
When one good is inferior,
One good is inferior. The idea is not that clear. আরেকটু বলো। I know when one good is inferior, the IC will become positively sloped. However, here the IC is still negatively sloped. The curvature is concave rather than convex. That means increasing MRS.
If we like consume the goods separately, not together,
Ma'am, I guess goods like which show that thing, like diamonds and all. Like
Like
some
that.
people purchase more
or like
diamonds
if
when
we
the value of
consume the goods
goes
separately,
increases,
in
so that they
convex
can
IC
show that diamond.
we consume them together, but in concave we might consume the goods separately,
Separately means?
like not together. If we consume X, we don't consume Y, something like that.
No, would you please repeat once again?
I was saying like if we consume X and Y separately,
Separately.
that is
Separately
if we
means, uh,
consume X, we
for
do not
example,
consume
I
Y.
I like to consume egg and bread. So separately means what do you want to mean? You are telling separately. Separately means what? Or what do you want to mean indicating separately?
That is if we consume like egg, we will not consume bread, or if we consume bread, we won't consume eggs, something like that.
No, in that case, why I'll talk about this thing, okay? The idea of concave indifference curve can be
Ma'am, may I tell?
captured. Yeah, yeah, yeah.
Ma'am,
Please.
ma'am, indifference curve cannot be concave because the consumers they want to have the more of a good.
I'm talking about the special cases, So, in general, conventionally, what will happen that we have discussed already. So now we are discussing several special cases. Okay, so we are considering concave indifference curve. Yes, China.
Ma'am, if we consider the two, one is a normal good and other is an inferior good, if we consider it like that,
In that case, as I told to somebody
the two
else,
goods we
the
are
difference
taking
curve
as an
will be
example.
positively sloped. Okay, if it is good and bad, in that case, the indifference curve will be positively sloped. We will like to get rid of one commodity and we will continuously like to increase consumption of other commodity.
Ma'am, for goods of conspicuous consumptions, like for diamonds, uh, if we consume more of the diamond, then our marginal rate of substitution will go on increasing. Because the rich consumers, for them, the diamond is a symbol of status. So they would like to consume more of, they would like to go on consuming more of that
So you are
good.
telling that, for the conspicuous consumption, we will have concave indifference curve.
Yes, ma'am.
And always we will have the equilibrium only at one corner.
No, ma'am, we won't have it at one corner.
Okay, Pema Dorja, you wanted to say something?
No, ma'am, I had the same thing as Shoparna.
Same thing. Okay. Okay, now think about a situation. You like both the commodities, say. I'm considering two commodities at a time. I'm considering, say, ice cream and sweets. Okay, so suppose you are fond of both ice cream and sweets. However, you don't like to consume them together. You like both the commodities separately, independently. However, you don't like to consume them together. Always, you know, one sweet, 3 cups of ice cream will be better than 3 sweets and 3 cups of ice cream. Or on the other hand, one sweet, 3 cups of ice cream will be better than three of both. This kind of situation. Okay. So you like both the commodities separately. However, at the same time, you don't like to have them together. So in our real life, on regular basis, when we think about a basket, it happens. In the basket, there are, say, 10 commodities, and I like to consume, among these 10 commodities, generally I consume 7, and in them there are certain commodities which are substitutes, which are complements, or which are unrelated. We are consuming all of them. And again, there may be certain commodities which I like to consume separately, however, not together. Okay. So if this happens, as we continuously move either to the x1 axis or to the x2 axis, my marginal utility will increase. Yes. Okay. So what I am telling that, so I have in my regular consumption, or it's not a very special set of commodities, I may face this kind of situation. Now, if I face this kind of situation, the point of tangency we are talking about, the point T, in any of the two diagrams, are nothing but local utility minimum. These points are nothing but local utility minimum. As we move towards A or towards B, my utility will increase. Okay, in the second diagram too, if either we move towards A or move towards B, my utility will start increasing because I don't like to consume x1 and x2 together. Okay, so if I have more of x2, I'll like less of x1, or if I have more of x1, I'll like to have less of x2 and I'll move towards higher indifference curve. Okay, so you look the lower indifference curve when we are getting the local utility minimum at the point of tangency. If I move towards A or move towards B, or for these diagram, as I mentioned, I can increase or extend the indifference curve like this using the dotted line, or I can extend the indifference curve like this. So if I move towards B, I can move to a higher indifference curve, still remaining on the budget line. Or if I move towards A, I can move to even another higher indifference curve, and that is also affordable to me because the point is lying on the budget line. This point of contact is lying on the budget line. Okay, so higher indifference curve is lying beyond this point of tangency. Higher indifference curve is lying beyond this point of tangency. Here I am getting point of tangency, that is the first order condition is satisfied. However, the T is not a utility maximum, rather T is only the utility minimum. So we will call it local minimum, local minimum. So T is only a local minimum. It is not at all a maximum. Though it is a point of tangency between the indifference curve and the budget line, though the slopes of the two curves are same at point T, though MRSXY is equal to Px by Py at T, this is only a local utility minimum, because if consumer starts reducing consumption of one of the commodities, consumer will be able to move on a higher indifference curve, still remaining on the budget line, still remaining on the budget line. Okay, so this is the idea. I prefer or I like both the commodities. However, I will not like to consume them together. So if this is a situation, as we move towards either of the axes, the situation will be better in terms of my satisfaction. So if this is the context, in that case, the indifference curve will be concave. Indifference curve will be concave. So please add. Let's consider a preference pattern of the consumer. Let's consider a preference pattern of the consumer where the consumer likes ice cream and sweets. Ice cream and sweets hyphen, but she does not like to have them together. But she does not like to have them together. In considering her consumption in considering her consumption in the next hour in considering her consumption in the next hour, she might be indifferent between consuming 3 cups of ice cream, 3 cups of ice cream and 5 sweets, or 5 cups of ice cream and 3 sweets. There is some substitutability between the consumption as we move along the indifference curve. Both the points are lying on the same indifference curve. 3 cups of ice cream, 5 sweets, and 5 cups of ice cream and 3 sweets. But either one of these bundles would be better than consuming 4 of each. Hence, the ICs are concave to the origin. Next, here the point of tangency between the budget line and the IC within bracket a point like T, a point like capital T, indicates the worst point and not the best. In other words, T represents a local utility minimum. T indicates or T represents a local utility minimum. Underline local utility minimum. And the consumer can increase her utility. The consumer can increase her utility by moving from the point of tangency toward either axis. Consumer can increase her utility by moving from the point of tangency toward either axis. Optimum will be achieved. When she consumes only one commodity at the limit. Optimum will be achieved when she consumes only one commodity at the limit. Okay. So this is the second case, allowing concavity. Case 3, third case. Relaxing the axiom of dominance. Case 3, third case. Relaxing the axiom of dominance. Relaxing the axiom of dominance. What was the axiom of dominance? More is better. That was the idea. More is better. Now we are considering consumer's equilibrium when we are relaxing the axiom of dominance. Now to understand this context, we will consider the indifference curve which is L-shaped. Which is L-shaped. Okay. So commodities are complement to each other. Commodities are complement to each other. So consider a case where we are measuring x1 along the horizontal axis, x2 along the vertical axis. Consider the budget line as KL. Consider the budget line as KL or MN because these points are not here. MN or KL. And then first you draw OG, this ray, OG. The ray along which consumption will take place, OG. Then you draw IC1 and IC2. The point where we are finding a point of contact between the budget line, blue budget line, and the indifference curve IC2. We are calling this point, point A. At A, consumer is consuming O capital E amount of X1 and O capital D amount of X2, OE and OD. We are considering one other point along IC2, that is point B. And dropping perpendicular from B along the x-axis, along x1 axis. Considering any other point C, which lies on a higher indifference curve, C. Call it figure 5. Everybody could complete the drawing? Yes or no? Still working on it?
Yes,
Could you
ma'am.
finish?
Complete.
Yes or no?
Yes.
Completed.
Okay. So please continue. In figure 5, ICs are drawn L-shaped. Already we talked with this kind of indifference curve, possibility of this kind of indifference curve, and you also know here consumption will take place only at the kink. That is, you know all these things. Just in context of consumer's equilibrium, I am putting the matter. In figure 5, the ICs are drawn as L-shaped. This implies that a point such as B a point such as B, is indifferent to a point such as A, a point such as B is indifferent to a point such as A, even though B contains more of one commodity and no less of the other. Even though B contains more of one commodity and no less of the other. Permitting A and B to be in different amounts, permitting A and B to be in different amounts indicates the relaxation of the axiom of dominance. Is relaxation of the axiom of dominance. Because at B, without reducing the consumption of X2, keeping the consumption of X2 at OD, consumer could increase consumption of X1 to OF from OE. However, this is not helping the consumer to move on a higher indifference curve. Actually, AB is redundant to the consumer. AB is redundant to the consumer given a fixed amount of X2 OD. And figure 5 permits weak dominance within inverted comma weak. Figure 5 permits within inverted comma weak dominance hyphen since a point such as C cannot be indifferent to A. Since a point such as C cannot be indifferent to point A, figure 5 permits weak dominance hyphen since a point such as C cannot be indifferent to A hyphen but not within inverted comma strong within inverted comma strong inverted comma close dominance. So there is some degree of dominance, however, that is only weak dominance, not strong dominance, which we get in context of negatively sloped, perfectly convex indifference curves. Okay, so that kind of dominance is absent here. Okay, and figure 5 implies that commodities are Figure 5 indicates that commodities are consumed in a fixed ratio. Commodities are consumed in a fixed ratio OD by OE. Commodities are consumed in a fixed ratio OD by OE. The ratio is shown by the line OG. Here, point A is indifferent to point B. Though B absorbs if B absorbs if more of x1, if more of x1 than does A. Though B absorbs if more of x1 than does A. Hence, the amount EF is essentially redundant. Hence, the amount EF is essentially redundant, and the consumer would have no incentive to end up and the consumer would have no incentive to end up at a point no incentive to end up at a point other than a corner point such as capital A. Other than a corner point such as capital A. Next, here the commodities are complementary to each other. For example, 1 cup of tea requires, here the commodities are complementary to each other. For example, 1 cup of tea requires, say, 1 spoon of sugar. 1 cup of tea requires, say, 1 spoon of sugar. More sugar in a sugar bowl, more sugar in a sugar bowl provided with each cup of tea, more sugar in a sugar bowl provided with each cup of tea does not affect the consumer in any way, does not affect the consumer in any way. Nor does extra tea with every 1 spoon of sugar, nor does extra tea with every 1 spoon of sugar. Next, the MRS is not well defined. The MRS, the marginal rate of substitution, is not well defined at the corner of the L. The MRS is not well defined at the corner of the within inverted comma L. Everywhere else, it is either zero. Everywhere else, it is either 0 within bracket along the horizontal portion of the IC, dx2 by dx1, dx2 by dx1 is equal to 0 by dx1, 0 by dx1 equal to 0. Everywhere else it is either 0 within bracket along the horizontal portion, dx2 by dx1 is equal to 0 by dx1, because along the horizontal portion the amount of x2 is not changing. So dx2 is equal to 0 by dx1, only one commodity is changing, so dx1 will remain as it is, and that is equal to 0, bracket close, or infinity, within bracket along the vertical portion, dx2 by dx1 is equal to dx2 by 0, dx2 by 0, x2 is changing, x1 remaining unchanged. So dx2 by 0, then put an arrow, infinity, moving towards infinity. Bracket close. Okay, so everywhere else it is either 0 or infinity. MRS is not well defined. For any kink, as you know, if it is not a continuous curve, if it is not a smooth continuous curve, we will be not able to define the slope of a curve. For this kind of kinky line, basically the horizontal and the vertical intercepts of the IC are cutting the budget line, or we cannot define any slope at any kink. So slope is not well defined. Only for a smooth curve we can define a slope. So this is all about relaxing axiom of dominance. If anyone have any question or any part you could not understand. Is it okay? Please
Yes,
open
ma'am.
the microphone and tell me, confirm whether you are understanding the matter, whether still I need to explain something.
Ma'am,
Is
it's clear.
clear? Okay. Next. So I think 1, 2, 3, 3 subcases done. Am I right?
Yes, ma'am.
Yes, ma'am.
Okay. So next. Satiation in one commodity. Satiation in one commodity. Satiation. Sation. Satiation in one commodity. Okay. Add. The axiom of dominance ruled out. The axiom of dominance ruled out satiation in all commodities. The axiom of dominance ruled out satiation in all commodities. Because axiom of dominance told us MIB, more is better. So there is no satiation. There is no satiation, okay? The idea you wanted to explain in context of diamond or, item of conspicuous consumption, this kind of thing. Axiom of dominance ruled out this kind of thing. Satiation in all commodities were ruled out. Okay, so always more is better. That was the concept. Let's consider a case. Let's consider a case where we consider satiation in one commodity. Let's consider a case where we consider saturation in one commodity. The indifference curve in this case, will take the indifference curve in this case will take the shape of a horseshoe. Let me first draw the diagram. The dotted line I have basically drawn for drawing the indifference curve perfectly. Just this point. Now I'm marking several points. Okay, horseshoe type IC. So what I have done, within the stretch BC, the indifference curve is perfectly convex to the origin. It is strictly convex to the origin. Indifference curve is strictly convex to the origin. Negatively sloped and strictly convex to the origin. However, reaching at B, indifference curve is becoming positively sloped, and similarly, reaching at C, the indifference curve is becoming positively sloped. Okay, so it is this horseshoe type of thing. Okay, so in a particular range, it is negatively sloped, but beyond certain point, it is becoming positively sloped. So this kind of thing, horseshoe kind of shape, I am considering. So beyond B, more of other commodity, more of a specific commodity is becoming bad to you. Similarly, beyond C, more of a particular commodity is becoming bad to you. So indifference curve is becoming positively sloped beyond certain points. Okay, so suppose you like, lobster very much. You like lobster very much, but you will be able to manage up to, say, 4 lobster a day. Beyond 4, lobster will become bad to you. Okay, so beyond 4, if you have lobster, to compensate the disutility, you will need more and more of the other commodity. To offset the loss you are getting, having more of lobster beyond 4, you need more of the other commodity to compensate the problem of say allergy or what kind of disutility you can think about. Okay, similarly, for the second commodity too, you can enjoy up to, you like the commodity, however you cannot manage beyond 7, say. So reaching at the value 7, the commodity becomes bad to you. So if this is the style of the commodity, if you are at point A, both the commodities are good to you, but beyond B, more of one commodity is becoming bad to you. Though B, D, they are lying on the same indifference curve, uh, you know, actually you are finding that B and D are lying on the same indifference curve, though at D, basically you are consuming more of, you are getting chance to consume more of both the commodities. Okay, so if I drop the perpendicular, and if I compare a point like B and D, we are finding that at D, we are consuming more of both the commodities. Okay, more of both the commodities. Still, the consumer is lying on the same indifference curve. Though the consumer is consuming more of both the commodities, however, both the points are lying on the same indifference curve. Actually, a commodity has become bad to you, and to compensate the loss or the disutility you are getting out of this, to compensate that, you need more of the other commodity too, more of the other commodity too. However, the slope of the indifference curve is positively sloped beyond B. And similarly, if I compare point like E and C, at E, you are consuming more of both commodities, more of both commodities. Compared to C, if you consume at E, you are getting more of both commodities. However, it is not lying on a higher indifference curve. It is lying on the same indifference curve because you are getting disutility out of consumption of one particular commodity. So if this happens, if you consume the commodities up to certain level, both the commodities are good to you. However, beyond an amount, the commodity is becoming bad in that case, we will get this horseshoe type indifference curve. We will get this horseshoe type indifference curve. Okay, so please draw the horseshoe type indifference curve. MN is the budget line. And I'm considering a curve which is convex between B and C, and A is a well-defined point of tangency. However, beyond B, the curve becomes positively sloped, and similarly beyond C, the curve becomes positively sloped. Between B and C, it is negatively sloped convex curve. The same diagram I have drawn here. Whatever you like to draw, you can draw. What will be the number of this figure? Is it 6 or 7?
6.
6, okay. So it will be figure 6.
Ma'am, please show the previous slide once.
The same thing. Okay, so please add. The point B in figure 6. The point B in figure 6 is indifferent to point A, indifferent to point A. But we also have BID. BID. D is also indifferent to B. We also have BID. Within bracket, instead of DPB. Instead of DPB, instead of D is preferred to be, instead of DPB, which we normally expect from the dominance axiom. Within bracket, instead of DPB, which we normally expect from the dominance axiom. Here, the consumer reaches a point of satiation. Consumer reaches a point of satiation in X2. Consumer reaches a point of satiation in X2 at B. Reaches a point of saturation in X2 at B. From B onwards, the consumer requires more of X1. B onwards, the consumer requires more of X1 in order to tolerate more of X2, in order to tolerate more of X2. Within bracket, that is after the point B X2 appears as the bad to the consumer. That is, after the point B, X2 appears as the bad to the consumer. Underline, X2 appears as the bad. X2 is no longer a good, rather it will be treated as bad. Similarly, C is a point of saturation. Similarly, C is a point of saturation with respect to X1. C is a point of satuation with respect to X1, so that C is a point of satuation with respect to X1, so that after C, the IC begins to, so that after C, the IC, the indifference curve, begins to bend upwards. IC begins to bend upwards through E. IC begins to bend upwards through E. Okay, so did you get up to this? So IC is bending beyond B and beyond C. So more of the other commodity you require, more of the good you require to compensate the loss you are facing out of consumption of bad. So you need some compensation. So though at D, you are getting more of both commodities, D is still lying on the same indifference curve. The same is happening at E. Though you are getting more of both commodities compared to C at E, however, both the commodities are not good. One of the commodities, that is X1, is bad to the consumer, and to compensate the loss, you need more of the other commodity, and still you are remaining on the same indifference curve. So first tell me whether you are understanding horseshoe shape of the indifference curve when you are getting horseshoe shape of the indifference curve. Yes or no? Are you understanding?
Yes, ma'am.
Yes,
To
ma'am.
repeat. So is it clear to everyone? I want to listen more yes, or if someone has some problem, please let me know. Shayantani Majumdar, is it clear to you?
Yes, ma'am.
Everything is clear. Yes or no?
Yes, ma'am.
Okay. Okay. Now the question is where or when the consumer will have equilibrium. The answer is equilibrium will take place in the usual part of the indifference curve, that is within the stretch BC. If the budget line is given by MN, the equilibrium will take place at this point where the convex curvature of the IC is touching the budget line. Equilibrium will take place at a point where the convex curvature of the IC is touching the budget line. So please add, existence of this type of saturation, however, does not affect, does not affect the equilibrium however, does not affect the equilibrium at however does not affect the equilibrium at A. Does not affect the equilibrium at A. Okay, so there is no problem regarding the equilibrium as long as we are getting horseshoe type of indifference curve. Equilibrium will take place only at the negatively sloped convex part of the diagram. Equilibrium will take place only at that point. Okay, so we will take a break for 10 minutes and then we will consider several corollaries out of these, and then we will consider the case if we find a situation that satiation in all commodities. Okay, satiation in all commodities. So first we will consider the case or cases where which are coming as the corollary to this case, and then we will consider satiation in all commodities after the break. Okay.
Ma'am, I had a doubt.
Yes, please.
Ma'am, does this mean that all convex IC curve become horseshoe when we extend them?
No, it's not that. For there are varieties of commodities in the basket, so it's not that all convex IC curves will become horseshoe. Okay, so we are talking about, when we are talking about the exceptions, we are trying to accommodate different types of commodities which we have in our basket in reality. Okay, so it is not that all indifference curves will become horseshoe, or between all commodities the indifference curve will behave like horseshoe. It's not that thing. Okay,
So, ma'am,
so for
how?
most of the commodities it might be more is better. For several commodities it may happen. Yes, you still
So,
have
ma'am,
some
how
question.
do we identify that commodity makes a normal convex shape and which one makes a
Would you
horseshoe?
please repeat the question?
Sorry, ma'am, there is a network error. Ma'am, how do we identify which commodity makes a normal convex IC and which commodity makes a horseshoe IC?
In general more is better. However, if it happens that beyond certain amount a commodity is becoming bad to the consumer, then only we will go for this kind of horseshoe shape. And this idea may vary from consumer to consumer. It's not that you know uh, beyond this amount for all the consumers the commodity will become bad. Okay, now when I'll discuss the corollary, I'll bring the idea of air or water pollution. Now if I consider pollution kind of thing, in that case from the very beginning it's a bad to all. Okay, however if I consider goods, it is not that, say bread and butter you are considering. Okay, bread and butter will be again a complementary set of commodities. I'll not consider that. Rather, let's consider egg and fish. Okay, egg and fish. Okay, so separately both the commodities are good to you. It is not that egg and fish, among this you have this kind of problem, the commodity becomes bad to you. So you will have a normal indifference curve, and given the budget line you will find out the point of equilibrium. Now there may be certain items beyond which the commodity may become bad to you. In that case it will have this kind of shape. Okay,
Ma'am,
Yes,
in
ma'am.
concave ICs, we use like unrelated commodities. So can this thing also happen like this inverse horseshoe or a concave IC?
For the concave IC, actually the point of tangency is the local utility minimum. And so what is happening to the extended part, we don't bother about that. We are interested about a solution which will help me to come out of more of one commodity, and we will like to consume lesser sweet and more ice cream either, or more ice cream and very less sweet, and we will like to move towards the corner. So in case of the concave IC, we are not interested about the extended part of a single IC, because the point of tangency is giving us only the local minimum. Okay.
Okay, thank you, ma'am. And ma'am, just another doubt, like, can you please upload like Wednesday's recording? It has